Hello everyone, Guten Morgen. Hello, my name is Anand. I'm co-founder of Rorolite, an illicit startup based in India. A couple of years ago, when I started working on a project where I had to deploy a machine learning model as an API, I realized the process of doing that is far too complicated for my taste. As someone who likes simplicity and right level of abstractions, I thought, does it really have to be so complex? Can this be made simple? Last couple of years at Rorolite, we've been trying to see if we can solve the problem and make it easy to deploy machine learning models as APIs. So in this talk, I'm really talking about not about what I've done, but more about the approach that I think is the right way to do. Here's the outline of the talk. We'll start with looking at overview of machine learning and see why it's important to run machine learning models as an API. Then look at the traditional approach, how people usually do. And then I'll take a small detour and talk about the importance of having the right abstractions, and then present our approach, the way what we're trying to solve. Again, a lot of things that what we've done is available as open source, so you can actually take it and actually use it in your projects if you want. And I'm going to talk about the direction we're heading, show how whatever tools that we've built is going to change in future, and summarize it. That's how this talk is going to be. Again, let me say it's not really about exactly the tools that I've built. It's more about the approach that I'm taking. So if you look at machine learning in a nutshell, all you're doing is you have some historical data with you, you take it, and then you train and build a machine learning model. Once you have a model with you, you would give live data to it and then get some predictions. In a nutshell, that's what machine learning is about. You can talk about whatever type of model that you have, decision tree, support vector machines, or deep learning. It's this in a nutshell. Then why do you really want to do this as an API? The problem here is the producer of the model and consumer of the model are kind of tightly coupled. What does it mean is, let's say as a producer of the model, I want to change the model to get a different version of the model. Have more data, I want to build a new model and put that in production. Then I have to tell the consumer, say, hey, I have this new model now, stop using the old one and start using the new one. Let's say I have changed the model from, let's say, decision trees to support vector machines or to a deep learning or something. Then the consumer has to update his code to use the new model because that's a completely new way of doing things. It's kind of tightly coupled. So how do you solve this problem? Like any other problem in computer science, any problem in computer science can be solved by adding one more level of redirection, right? So what do? You put an API. What's happening here? The consumer of the API is not using the model directly, but there's one level of redirection here. They talks to an API, and API talks to the model. What's the advantage of this? Now, the producer of the model is free to replace the model at his will without having to interact with the consumers. So it's really loosely coupled so that the producer can change the model as long as the API is the model stays the same. Right? So you can change from decision tree to support vector machines or deep learning or retrain the model and then put a new model there. And that doesn't affect the consumer at all. So that's why we want to, it's a good practice to deploy machine learning models as APIs. Not only that, there may be a lot of different people using our APIs. There may be a lot more requests. So we may want to kind of scale to kind of meet those demands. When you have an API, you can run multiple copies and then put some kind of load balancer or whatever. So that kind of takes away the problem of scaling and then meeting requirements away from the model building part. So that's again separate problem that you can worry separately than model building and prediction. Okay, so now we have seen what is machine learning about, and we now convinced ourselves that it's good to run it as an API, but how do you do that? The problem is now, how do you run that as an API? Right? So if you, this is where the problem comes. So let me ask you a question here. How many of you are data scientists in this room? Okay. How many of you have deployed model as an API before? How many of you have not done it but want to know how to do it? Okay, that's a fairly good number. Okay. Now, if you Google for it, how to deploy ML model as an API, you'll get some picture like this. The different sets of tools that you need to know. You need to write Flask, some web framework, run with GUnicorn, put it behind Nginx. Well, people say, no, that's not a good way. You should actually do serverless, do AWS Lambda. And some people will say, you actually have to put it in a Docker container, or you have to run it in systemd, make sure that it restarts automatically when the node restarts and all that. There are a lot of different things that kind of goes in when people talk about running something as an API. Now, this is where I have a problem with. Well, you may need all of these things, but does it have to be so complicated? As a data scientist, I want to have a simple model. I want to run this as an API and then share it with my customer. Do I really have to worry about all these things? It's going to take me a month or two to kind of understand all of these things, right? Is there a better way? So, here is where I want to kind of take a small detour and then show you something. You see this? This is called Flapping Bird. This is made of a square sheet of paper. You hold it like this and then pull its tail, it flaps its wings. Okay? It's a really nice toy. Give it to any kid who would start playing all the day. The interface is very simple, right? You hold it like this and pull its tail. It just starts flapping its wings. Okay? It's very easy to explain to any kid as well. But let's see what goes in actually building this. It's made of a square sheet of paper, and you see those lines there. There are two different kinds of lines. There are the dotted lines and the dashes. Okay, that tells you what kind of fold you need to make. For someone who have never done origami, this is something pretty complicated. Okay, it would take a couple of hours, even a day, to kind of figure out how to do this. But look at how simple the interface is. Okay, so when we talk about systems that are complicated, there are two things we really talk about. One is the complexity of the interface and complexity of implementation. If you look at this case here, the interface is very simple. Just have to flap, just pull the tail. But the implementation is kind of fairly complicated, right? Now, for that matter, think about electricity. How do you turn on a light bulb? Go and then push a button, right? When you turn on a light bulb, do you really think about what goes behind the scenes? Do you think about giant generators powered by steam, wind, solar, and the gigantic network of transmission lines? You don't, right? You just push the button and then light is on. Then, why do you have to worry about so many things when you're deploying a machine learning model? Shouldn't it be like a push button? Right? So that's what I thought, and been spending time to kind of solve that problem. So let's come back to our problem. What we want to do is take a model and then convert that to an API. So what I really mean by model to an API, there could be different kinds of models, right? You could have scikit-learn model, TensorFlow model, Keras, PyTorch, or something else. We should be able to convert any of them into an API. Well, that looks like a difficult thing. So let's put something in the middle again, like one more level of redirection here. So you write a predict function that knows what kind of model it is, and then turn that into an API, right? So now we can solve the problem from deploying a machine learning model as an API to running a Python function as an API. It's the same thing, but we don't really have to worry about now what's inside the function. Take any Python function, run that as an API. So this is what we set to solve. So build a tool called Firefly. It's an open source tool to turn any Python function into an API. All you have to do is pip install Firefly Python. Let me show you how to use that. First, step one, write your Python function. I wrote a simple function square, but that could actually be your machine learning model, predict, etc. It takes a number, computes the square, and returns it back. Now, how do you run this in API? With Firefly, you say Firefly module name dot function name. Voila, you have an API up and running. Isn't that cool? Not only that, Firefly comes with a client library. You can create a Firefly client and give the URL, and that exposes you the same function that you started with. So you call it as if you're calling a local function, api.square, say n equal 4 and give 16. Behind the scenes, it's sending an HTTP request to the server responds back with the number, and client gives you back the same thing. So it takes away all the nitty-gritties we're talking about, a web server, and all the things that we're talking about that powers all of it. It's kind of abstracted away, just like light bulb. You just push and you have a light bulb on. So you write your function, run it as an API, and then start using it. And everything else is kind of taken care behind the scenes by the framework. Okay. Now, you may be wondering what's this magic. It's nothing magical about it. It's a simple RESTful API. You give n4, send a post request to that endpoint that gives 16 back. And the client, that library that we have, what it does is client looks at what all functions are available and then makes a request appropriately. What about an ML model? Well, it's exactly the same thing. So instead of writing square, I write a predict function. So I use joblib here in this example to load a model from a saved file and then predict. That takes an image as argument, predicts something, and returns whatever results is appropriate here. And excuse me, you run that as an API and start using with the client. Create a client, create an image with the URL, pass it, that gives the response back. Isn't that nice? Okay. Well, we're only talking about, but there's one thing here is converting a Python function to an API, but it's really running locally on your machine, right? It's not really deployed anywhere. So if I say Firefly square.square, it's actually running the API locally on my machine. But that's not what really we want. We really want to have a production quality API that we can share with our client or something. Now, that's not what Firefly does. Firefly only worries about converting any Python function to an API. So what we've done is we've built a platform to solve this problem. So what we want to do now is take a Python function, deploy, and get a URL. So we built a deployment platform at Rorolite. So what you do is you create a simple config file that says what's the project name, what is the runtime. So runtime is a basic software environment that the project starts with. In this case, it's a Keras project. And specify the services that you want to run as part of this project. What's the service? Typically a Python function as an API. Give a name to it and then say what function that you want to run as an API. The module name dot function name. It behind the scenes starts a Firefly server, and when you deploy, gives you a URL that you can start using. Okay. All you have to do is run deploy. Behind the scenes, it takes your code, packages it as a Docker image, starts the services, set up HTTPS and all of it. Again, these are the details you really don't have to worry about. Right? Do you really worry? Same thing as electricity, right? You turn on the light bulb, bulb is on. You don't really care about what's happening. Same like that. I mean, this is what's done by the platform, but you don't really have to worry about all these things happening there. The interface is simple, right? You write your Python function, specify your configuration, what you want to expose, and then deploy the push button, and you get your URL up and running. It may be doing all these things in the behind the scenes, but you don't really have to worry about all of it. That may look like too simplistic model, right? Write Python function and then deploy, I get an API. But in practice, you may have so many other things to worry about. For example, I have my own custom Python dependency. How do I install this? I depend on one particular Python library. So what you do is, you write a file requirements.txt. the Python standard way of specifying dependencies. The platform borrows the report to Docker interface from Binder project. How many of you know about Binder? Not too many. Okay. So Binder is a project from Jupyter. So they have a nice project called report to Docker that basically specifies an interface to provide dependencies. What we did is, instead of reinventing our own way, we just followed the same interface. Though we don't really use the same project, we just stick to the same interface so that users don't have to learn a new way of doing things. The way it works is, you can write your requirements.txt file and specify all the Python dependencies. That's the first level. If you're not happy with that, you want to install some system level packages, you can write an apt.txt, app.txt, which is for Debian or Ubuntu. That installs the system packages. If you're not even happy with those two things, you can actually write a post-build script that says, that's a shell script that you can decide to do whatever you want. So all these things gets run every time you build the project. Let's say you want to use a GraphQL, what's that? Dot or some other Python library, Unix executable that you want to use here. So you can specify that as part of the post-build script. So that's how you specify all these dependencies. So even though the platform is allowing you to deploy them in a simple way, it doesn't really stop you from doing other things. So usually what happens is, when you kind of build a platform that solves 90% of the problems elegantly, but remaining 10% of the problems, you have to kind of work around it. It becomes too difficult to do. So what we have kept in mind from the beginning is that it's an open platform. It doesn't really stop you from anything that you would otherwise be able to do. Okay, so far so good. Now I have an API to recognize any object in an image. The project that I have here is image recognition. What it does is, given an image, it tells you what is inside the image. Okay, now I want to build an app. So what it does is, click on image, it tells you what's inside the image. I don't know, any of you tried doing things like that? So what I'm trying to do is to build a simple HTML app that would call the API that we've built now and show the predictions here. So what's happening is, the first thing I do here, I get this weird error. Has anyone of you seen this error before? It's a cross-origin request blocked. What does it mean is, browser has a security module that does not allow any web page to send requests to a random website. Why is that? Let's say you are on my web page. If I send a request to Gmail to reset your password, would you be happy? No, right? So what browser does is, browser only sends a request to a website only if it says that it accepts requests from the current domain. So for example, Gmail would say that it won't accept those kind of requests from anyone. But in this case, the page where we have this is trying to send a request to our API, but the API should actually say that, hey, I'm an API, I'm okay to accept requests from anyone, I don't really care. How do you do that? Now, if you're building APIs by hand, you get into these things every time you build an API. You end up solving these problems with every API that you build. So with the platform approach, what you can do is just add this one line there, allow origins start. I want to get it from anyone, and then deploy again, and that would start working. So that would start working if you add that single line there. The idea is here not about what exactly I've done, but look at the level of the kind of abstraction that we're trying to build here. Okay, we decided not to build APIs by hand, have a library that does it, and there is a framework that deploys things for you, so you can extend that to support any of your needs, and you do it once and it's solved for all the APIs that you're going to build in future. Now we can extend this further and say specify size and scale. Size, specify the instance size that I want so that I can scale vertically. I want to put it in a bigger instance so that I can handle more requests. Or specify scale. I want to run multiple of these things, so scale horizontally. Given that we started with a simple declarative interface, it allows me to expand what I have and have support for all these things. Again, so the Firefly is an open source library that enough of you use, but the things I'm talking about right now, all these things are part of the platform that we built at Rorolite. So what we thought is, it's a really nice interface. What if we can make a light version of this open source? So we have a version of that, it's called rorolite, that speaks the same interface. The only difference is, if you look at the implementation here, you can decide the instance size and how many of them you want to run, etc. But whereas with an open source version, you're always running it on one single server. You say rorolite deploy, and it deploys the thing exactly in the same way. Fine. So we have a library for deploying, converting Python function to an API, and we have a platform to take it to production and then deploy it and give a URL endpoint. So we have we started using it and realized that there are some things that would be nice to have some more features. So working on extending Firefly. Again, it's an open source project. You're welcome to contribute. And the couple of changes that we're planning is, I'm really excited about these upcoming changes. One is we're making the API extensible, adding support for Python 3 type hints, automatic API documentation, and support for gRPC. Let me explain what I mean by this. So the new API would look like this. You create a Firefly application, and then specify what function you want to expose as an API. For example, I have a function to detect outliers that takes pandas data frame as an argument and gives a pandas data frame back. Okay. Now, current version only works if your input and output is JSON friendly. So what we're trying to do now is to work with custom data types as well. So Python 3 has this nice feature where you can annotate your types. You can say that the first argument, detect outliers, takes a pandas data frame as argument and gives data frame back. Now, if the framework has support for serializing data frames, I don't really have to worry about how to give input and how to take input. It's completely taken care by the library. For example, you want to write an image processing API or detect faces in an API, in an image. It takes image as argument and gives a list of images which are the faces which are detected from the image. What does it take to write this in API? You have to worry about so many things. How do you pass an image? Do you pass base64 or do you pass as a URL? And then how do you send it back? Do you send it as bytes or do you send it as base64? So many things to worry about. What this approach gives you is you specify how to convert images, how to convert bytes to image and image to back to bytes or JSON, whatever it is. You can just write the function like that, and then that will be available as an API. So this is something that is not there yet, and we're working on. Again, the other thing is to have an API documentation. So what it does right now is it looks at the functions, picks the doc strings from that, and then makes them available, but it doesn't really provide a human-readable documentation. What we're working on is to make that possible. So when you go to an API page, it starts showing you the documentation, which is automatically generated. You don't have to worry about it. So adding planning support for gRPC, because gRPC is a RPC framework from Google, which is more efficient when you're working with large data sizes. So what I'm going to do now is I'm going to show you a short demo of these things, how it actually works. Let me go here. Display. Okay. So I have, let me stop this, start a new one. So I'm logged into the Rorolite platform, starting a notebook. When I start a notebook, I can actually specify what size I want. I want to start what instance size I want. Whether I want to start a GPU, K80 or Tesla as well. And then that gives a notebook here. It's taking a couple of minutes to start that. Okay. Yep. let's see here. So I have a image prediction.py. It's a predict function that takes an image, number of predictions. It resizes image to one appropriate size. Maybe you can make it slightly bigger. And tries to get predictions from EG16 model. It tries to predict and then doing some post processing to get label and probability from that and then return it back. I want to run this as an API. So what do I do is try this. Let me kind of comment this part for now. Right. So this is the config file. It says I want to deploy. Sorry, I think sorry, I was using the other function here. Okay, the predict function here from this file. It reads image and predicts the image. So predict image basically does the same thing what we've done earlier. I want to run this as an API. So specify what module and what function that I want, instance size, and want to enable cards. And then okay, so I have these things here. I have a roro.yml file here, which is the configuration file for the project. I say I run and deploy. What it does is it takes all the code, send it to the server, and then starts the API that is specified here. Let's see if it's working. Okay, so this is an API. Oops, guess it's going to take a minute to start it. Oops, it's wrong. Let's give it a minute. I'm sorry, it's taking a minute to kind of load it. Okay, what it does is it looks at whatever you have given and it picks a doc string and it kind of gives you a JSON at this point. But what's interesting is now I have a simple HTML one single page application that will to predict things there. So I can deploy that as a part of the project. And let me deploy that as well. So if I run deploy again, now it's deploying two services. One is a Python function as an API. The second one is the HTML page. So what happens is it actually sends all the directory to the server. That creates a Docker image and then starts appropriate containers in the cluster and then gives and sets up URL endpoints. At the end, we'll get these two URLs. One is image recognition demo, anand.oracloud.io, and there's an API. So both of these things. Now, let me kind of, here it is. Okay, click on any of them. What's happening here? Oh, smile. I thought the cards is so. No, it's not elephant, it's too big. Oh, cards is on, okay. Did I miss something? Yeah, let's see if. Okay, it says cards error, but I thought we have fixed the cards error. Let me just see. Let me just a minute. Let me see if it's actually calling the right. Sorry. It should really be on. Well, I'm sure some Murphy's kind on me, I guess. But the idea is it would send request to the API and then get it back. Maybe I kind of missed something here, but let me kind of, well, let's not go there. So Let me get back to. Yeah. So the idea is you write a file like that and then do a deploy that would give you your endpoint that you can use. Maybe kind of have some error in the configuration. Didn't work right now. But yeah, so the summary is deployment machine learning models need not be so complicated. It can be simple. The key is focusing on reducing the complexity of the interface. As engineers, we often forget to distinguish between the interface complexity and implementation complexity. So when you're deploying models, we kind of so it's really important to focus on the complexity of the interface. We should reduce the implementation, the interface complexity. When the implementation is complex, it's paid by the developer who is building it. When the interface is complex, it's paid by the user, and every time uses that. So it's very, very important to focus on the interface complexity and try to reduce that complexity. If there's an implementation complexity, you may be complex the first time, you can actually improve it later on. But if it's an interface, that's kind of really hard to change once it's out. And our work is open source, you can build on it. We're planning to build new features that I've shown. If you're interested, happy to collaborate and work on it. And I'm open for questions. And yep.
So we have time for questions.
Sure.
Yeah, thanks for the nice presentation. One thing I'm curious about is a lot of people, even when you automatically generate the Python client library, they still will want something more, like for instance, use it directly from command line. Do you have any plans to also automatically generate, for instance, command line parser from the information? Okay.
So let me repeat the question. The question is are there any plans to generate a command line client as well? The answer is no, because you can already use it in command line. Let me show you. Yeah, so you can actually use it from command line like this. It's just a RESTful API. You can still send requests and get it. So we have a client in Python, a client in JavaScript. We never felt a need to do anything in other languages. For example, if someone wants to use from Java, it's not hard to create a client, Firefly client in Java. So you don't have to build the client for each and every language, each and every API that you have. You have to write a client once for Firefly, and that's available. That will be used for any API that you deploy using Firefly. So that way, it's not that hard. Okay. Any other questions?
Would you say the built-in web server is really production ready, so also scalable when it comes to?
Yes. Okay. Okay. So the question is it production ready? Can it run in production and scale well? And the answer is yes. At the end, it's a WSGI application in Python. So you deploy it in a way that you deploy any other Python web application. So in production, what we do is we deploy it using GUnicorn. And so in fact, the new version of the platform, what we're building, we're deploying it on Kubernetes. So what it does is it starts multiple pods and puts load balancer automatically. And the moment you hit the URL, it distributes the load across all of them and gets it. So it's kind of production ready in that sense. Yes, please.
Large, and how the handling is loaded is one time you load it in session. Yes, question what's going behind the scenes.
Okay, the question is what happens when you have large models? What's the impact of large models on the application? The thing here is you can load the model every time you do prediction, or you can load the model at the startup of the program. So what is good is to do it at the beginning of the program so that you don't incur the cost for every request. Even then, if the model is large, it would add to the startup time, not to the prediction time. So what would be good is you run multiple replicas of the same application, same model. So you don't have one model running, but there are multiple copies of it running there. So when you restart it, you don't restart all of them at once. You restart one, and then that's up. Then you start the next one. So when you do it this way, there won't be any downtime. So even though model is large, it would take more time to restart your whole application, but that won't affect you in any way. Yes, please.
Bunch of questions. The first one is, I never read that you are kind of a framework agnostic. Could you share us by your?
Yes, you're right. So the question is, are you framework agnostic? The answer is yes.
Okay. And if you speak about TensorFlow, they have a special system called TF serving.
Yes.
For processing this, are you supporting this?
I haven't really looked at the question is, are you supporting TensorFlow serving? The answer is, frankly, I have not really looked into it because most of our work is in Keras, so we're kind of happy with what we have.
Okay. Do you have any numbers on the throughput? Like how robust is it? How many?
Okay. The question is, do you have any numbers on throughput? Frankly, I haven't really spent time measuring that. We never had a need for such kind of things. But let me say that this is, it won't have any impact on that because at the end it's a WSGI server. You start as many servers that you want and it scales horizontally based on that.
It would be nice to know how many requests do you just can be processed in your platform in a second.
So I think it really depends. The question is how many requests the platform can handle. The answer is it depends on what model you're serving. If you're serving a simple decision tree model, that would be very fast. But if you're doing something on a deep learning model or something, that may take longer time. So yeah, the answer is, frankly, I've not done it before. I don't have numbers of the on my head to kind of answer you right away.
What about authorization? So if I would like to post this API, not to enter into them, but just
Okay. Sure. So the question is there any way of authenticating the API? The answer is yes. So when you start the Firefly, you can specify an authentication token, and then it only works when you give the token there. Again, so there are a lot of things that I haven't really mentioned about because the purpose of the talk is to kind of talk about the importance of having the right abstraction and the right interfaces. There are a lot of other things that Firefly can do, which I haven't really mentioned. For example, you can say, give an authorization token when you're starting it, and you have to send the same token when you use that thing as well. So that way you can secure that in that sense. We're also working on ways to kind of provide different plugins for authorizations. So instead of having just one single token, can we have different API tokens and then somehow figure out automatically and all that? So there are the kind of things that we are working on, but that's not done yet. Yes.
Is there support for collecting the logs from your function or for measuring metrics and aggregating them?
Yeah. So the question is there support to collect logs from these functions? The answer is it's work in progress in the platform. So what we do is we have two different ways of collecting these things. One is, given any API, you can say that to collect the input and output of the API. So it would record automatically what the API is seeing and what it's predicting back, so that you can connect that with the actual outcome and see how well your API is performing. The other thing is, you may want to log some information from your API itself. So what we're trying to do is to provide these abstractions so that whoever is deploying these models doesn't have to really worry about setting up database and where that go, etc. So planning to do all of them as part of the platform, but that's still work in progress. We have not done that yet. Any other questions?
What happens in case of an exception to the client that also giving back the reason in the stack trace?
Okay.
What happens on and off of production?
Yeah. So what happens when there's an exception? Yes. So it gives back the same exception to the user. Okay. Is there a way to get progress notification or doing it async? The answer is no. The API doesn't support async at this moment. So what we have done in some cases where we needed something like that was when we submit the API, call an API endpoint that would start an offline task and gives back a task ID, and you can poll and then check what's the progress. That's something done externally, not part of the framework. Any other questions?
So there are no more questions. Thank you very much.
Yeah. Thanks a lot.